This video is over exponents and scientific notation. So we're going to focus more on scientific notation again in this video. And this time we want to represent each of the following numbers in standard form. So this time the scientific notation is provided. So we want to change that to an actual numeric value. So in this example here, each day an estimated 1.2 times 10 to the 9th beverages consumed throughout the world are Coca-Cola products. So yes, that's easy to read, 1.2 times 10 to the 9th, but it doesn't give us an actual good idea of how many beverages are Coca-Cola products. So we're going to change this back to a number so you're actually able to see how large or how small that numeric value is. So we know there's a 1 and a 2 in the notation somewhere. And we know that the exponent of 9 means it's going to be a super large number. So for this super large number here, we know it's going to be adding zeros on at the end instead of before. If it was a negative number, we'd add numbers on before. That would make it into a decimal. So what we're going to do here is we know this decimal place between the 1 and the 2 is being moved 9 times. And because we're adding on zeros at the end, we're actually going to move that decimal 9 times to the right. That's what that exponent 9 tells us. So all I'm going to do here is I'm going to move this decimal 9 times to the right. I guess I should, we'll just do it right here, it's fine. So I'm going to take the decimal and move it 9 times. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in each of those little, I guess you could say, dips, I'm going to add in zeros. Remember, we're adding in zeros at the end here. We're not going to add in other numeric values besides the zero. The zero is just like a placeholder. So we're really adding in 1, 2, 3, 4, 5, 6, 7, 8 zeros after this 1, 2. So I'm going to add in my 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to make this pretty. I'm going to put the commas in so I actually see how big the number is. So commas go between sets of 3. So really, this 1.2 times 10 to the 9th is the same thing as 1,200,000,000,000. So each day throughout the world, 1,200,000,000,000 Coca-Cola products are consumed. And this gives us an actual value to look at as opposed to scientific notation, which is easy to read. Let's look at one more example here where we're representing scientific notation in standard notation. So we know the mass of a grain of sand is approximately 3.5 times 10 to the negative 10th kilograms. Again, that was easy to read, but we don't know the actual largeness or smallness of that grain of sand. We know a grain of sand is small, but we actually want to see numerically how small it is. So we know in our answer we're going to have a 3 and a 5. And we know our exponent is a negative value. So we know we're going to add zeros before that because it's going to make it into a decimal. It's just a matter of how many zeros we have to add in. So because we know this is going to be a decimal or small number, we're actually going to take my decimal point and move it to the left. And we're moving it to the left 10 times. So just like we did in the last example, I'm going to take my decimal between the 3 and the 5 and move it to the left 10 times. We're moving it to the left because the exponent is negative, which means we have a small decimal. So just count it out. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we add in zeros for each of those little dips. So count how many zeros you add in. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros that we're adding in before this 3, 5. So again, I'm just going to count it out here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know the decimal place goes before it. And if you really want, you can add in the 0 before the decimal place. It's not necessary. Again, that 0 is just a placeholder. So we know the mass of a grain of sand is approximately 3.5 times 10 to the negative 10th kilograms, or we know that it's 0.00000000035 kilograms, which shows you how extremely small that grain of sand weighs.